What's up everybody, welcome to another video, and I hope you're ready to flex those brain muscles. In this video I'm going to do some examples of problems that use the half and double angle formulas. So what I've done is I've put some examples together and put them into a worksheet, and the link to that worksheet is in the description below. If you want to see the problems I'm about to do, check that out. And what I recommend doing is trying some of these problems on your own first, then using this video as a reference, especially if you're studying for an exam or something. I think that's the best way to test yourself and really try to learn this, is try this on your own first, then come back to this video, and I'll have timestamps in the description below as well, so you can skip through and find the problems that you need help with and make it a little easier for you. So hopefully this helps you if you're in trigonometry or precalculus or whatever. Well, let's go ahead and jump into the first example. So we're going to find the exact value of the cosine of 22.5 degrees using our half angle formulas. And it turns out this is a perfect candidate to use our half angle formulas, because what we have is the cosine of an angle, and this angle is half of an angle that we know and that we're familiar with, right? 22.5 is half of 45. And we know the exact values of all of our trig functions at 45 degrees. So that's what makes this a good problem to use the half angle formula, because without that formula, we'd have to use a calculator to find this exact value, but now we can do it by hand. So that's pretty cool. So let's recall our formula, and I'll probably, as the video goes on, have formulas kind of pop up on the screen here and there. But our formula says the cosine of theta over 2. So we have to be careful here, because I see some confusion happen around this. This 22.5 is not theta. This 22.5 is theta over 2. So the first thing I like to do when finding exact values like this is rewrite the cosine of 22.5 as the cosine of something over 2. And the easiest way to do that is just multiply 22.5 by 2 over 2, right? 2 over 2 is equal to 1, so we're not actually changing the angle. We're just rewriting it in a form that makes sense for the formula we're about to use. So this is equal to the cosine of 45 over 2 degrees. And now we have it in the form we want. So our theta is 45, right? Which makes sense, because that's really what we want, is a theta that we know and that we're familiar with, so we can use our formula. But our theta over 2 is 22.5. So just make sure you're aware of the difference between those two things. And I like to rewrite it this way to start, because now I can just jump into my formula. So the formula says that this is plus or minus the square root of, let's see, with cosine it's plus 1 plus cosine of 45 degrees, which, remember, that's why we wanted 45. Hopefully we know the cosine of 45 degrees. And this plus or minus is determined by the quadrant of our theta over 2, our original angle. So we're going to look at this cosine of 22.5, think about which quadrant this angle is in, and whether cosine is positive or negative in that quadrant. And I like to do this right away so I can make sure and get this sign correct right off the bat. So first quadrant, they're all positive there, so we can just erase this. We know that this value is going to be positive, but always check that right away. So now I can continue. The cosine of 45 degrees is root 2 over 2, so I have 1 plus the square root of 2 over 2, all over 2. And this is technically the exact value of this original expression. So how far you continue is really up to how much your instructor wants you to simplify. But I am going to continue as far as I can go and try to make this as simple as I possibly can. So first thing I'm going to do, let's see, I'm going to rewrite this 1 as 2 over 2. And the reason I'm going to do that is because that will give us a common denominator. And now I can combine this by just adding across and keeping the denominator the same, right? So I still have this big square root, and then I have 2 plus root 2 over 2, all over 2, right? 2 plus root 2 all over 2, and this is all over 2. Be careful here, don't make silly mistakes. The way I like to think about this is that we have a fraction over a fraction, because I can write 2 as 2 over 1. And now what I can do, when I divide two fractions, I can think of it two ways. I can multiply by 1/2 over 1/2, or I can flip the bottom and multiply across. They both mean the same thing, just two different ways of thinking about it. So flip the bottom, multiply across, but this all stays in the square root. So now what we have is, let's see, 2 plus root 2 over 4. And we're getting there. This may be good to leave here, but actually what I'm going to do is take advantage of one of the rules we have involving square roots. And that rule is that if we have the square root of like a over b, these are real numbers, then that's the same thing as the square root of a over the square root of b. And the reason why I want to use this is because 4 is a perfect square, and if I split this up, I can write this as 2, right? So you could probably leave your answer like this. I mean, it just depends on your instructor. So just ask them, make sure you know their expectations. 2 plus root 2. But we can't really get around this big square root with the square root in it. There's not much we can do there. And this is the final exact value of this original expression. So if you take a calculator, punch in cosine 22.5, and then punch this in, they should be the exact same thing, and we are done. All right, so here's our next example. We're going to find the exact value of the sine of 9 pi over 8. And it turns out that this is half of an angle that we're familiar with. It may not look like it, but half of this angle is 9 pi over 4, right? And the sine of 9 pi over 4 is the same as the sine of pi over 4, because the difference between those is just 2 pi, right? So it turns out that it may not look like it at first, but half of this angle is an angle we're familiar with. So we're going to start out the same way. We need to write this as the sine of that angle, 9 pi over 4 over 2, right? So our theta is 9 pi over 4, and our theta over 2 is always this original angle that we're dealing with. And if it takes you a second to figure this out, that's okay. It just takes a little bit of practice. I always think of it as my denominator gets cut in half, and I put all of that over 2. That's one way to think about it. So let's continue from here. Let's use our formula. So this is the square root of, and we're going to write this plus or minus, and then we're going to think about whether this is a plus or minus. Right away, we're going to figure this out. So let's see, 9 pi over 8. Remember, we always look at our original angle. Don't look at 9 pi over 4. We're looking at 9 pi over 8. What quadrant is that in? Well, let's think about it. Let's see, this is 8 pi over 8. That's pi, right? And we're going a little bit further. So we're actually down here in the third quadrant. Sine is negative down here in the third quadrant. So we're going to actually have to have our negative out in front here. We're going to have a negative out in front. And I like to figure that out right away. Just get it over with, write the negative there, and then make sure to carry it through the problem. Don't let it get lost. So let's go ahead and jump right into our formula. With sine, we have 1 minus the cosine of 9 pi over 4 over 2. And again, the cosine of 9 pi over 4 is the same thing as the cosine of pi over 4. We can just subtract 2 pi, and the value of the trig function is the same, right? So this equals negative square root of 1 minus cosine pi over 4. Let's see, that's root 2 over 2. So 1 minus root 2 over 2, all over 2. And I'm basically going to do the same thing that I did in the last problem. This probably looks a little familiar, right? I'm going to write 1 as 2 over 2. I'm going to combine those. Really, the only difference is I have a minus in here and a negative out in front here, but very familiar to the last problem. So if I rewrite this 1 as 2 over 2, then I have negative 2 minus root 2 over 2, all over 2, and I think of this as a 2 over 1, and I basically multiply by 1/2 over 1/2, or you can think of it as flipping and multiplying across, right? And this equals, I'm going to not lose my negative, let's write it with every step. Let's see, square root of 2 minus root 2 over 4. 2 minus root 2 all over 4, and I'm going to do the same thing. I'm going to break this up, and that's going to be negative square root of 2 minus root 2 all over 2. And that's going to be my final exact value for the sine of 9 pi over 8. That's it. All right, so here's our next example. We're going to find the exact value of the tangent of 7 pi over 8. And I will say that for tangent, there are a few different half angle formulas available. So really it's personal preference, or maybe the preference of your instructor. Maybe they want you to use a specific half angle formula for tangent. But I'm going to use the one that's 1 minus cosine theta all over sine theta. That's the one I like, so that's the one I'm going to use. But again, they should all get you the exact same thing. Okay, so I want to start out the same way. I want to write this angle as something over 2, right? So I use the same sort of little shortcut that I use, which is I cut the denominator in half and I write it over 2. That always works out, right? So my theta in this case is 7 pi over 4. And my theta over 2 is the original angle, right? So this is equal to 1 minus the cosine of 7 pi over 4 all over the sine of 7 pi over 4. And if you're using that other formula where you have the big square root and the plus or minus, be careful because this is going to be negative. Make sure you always check that. Just want to remind you. So let's continue from here. We know the cosine of 7 pi over 4 and the sine of 7 pi over 4, so we can just go ahead and write those exact values. Cosine of 7 pi over 4, root 2 over 2, right? Root 2 over 2, and then the sine will be negative root 2 over 2. Negative root 2 over 2. Now I'm going to do pretty much a similar way of simplifying. I'm going to write this as 2 over 2. I'm going to combine those in the numerator. Let's see, that's 2 minus root 2 over 2 over negative root 2 over 2. And now when I end up flipping the bottom and multiplying across, these 2's will cancel out pretty nicely, right? So I can think of it as multiplying by the reciprocal of the denominator over itself. I just think of it as flipping and multiplying, so negative 2 over root 2. These 2's cancel pretty nicely. I have to be careful with this negative. It has to go to everything. So let me make sure I be careful with this. This equals negative 2 plus root 2 all over root 2. Negative 2 plus root 2 all over root 2. And I think once I multiply by the conjugate over itself, basically, right? Root 2 over root 2 to get rid of this radical in the denominator, this will work out pretty nicely. Let's see if it does. Root 2 over root 2, that equals. So that's going to give me a 2 in the denominator. This is going to become negative 2 root 2 plus root 2 times root 2, that's 2, all over 2. Now these 2's cancel, right? I can either think of it as splitting this up into 2 terms. I can factor out a 2 from the numerator. Either way, all of these 2's cancel. What I'm left with is just negative root 2 plus 1. And that is the exact value of our original expression. This one actually turned out to be the least ugly of the 3. We got it down pretty nice. So punch both of these in the calculator. You should get the same thing, and that's it. All right, so here's our last example for this video. It's 4 parts. It's pretty involved, but I think it's a great example. It really tests our knowledge of these trig functions. We get to draw a triangle, use Pythagorean theorem, lots of fun stuff. So let's go ahead and jump into it. We're given the tangent of theta is 4 over 3, and we're given that theta is in this interval, so the third quadrant, right? And we're asked to find the sine of 2 theta, cosine of 2 theta, sine of theta over 2, and the cosine of theta over 2. So in order to find all of these things, we need to know the sine of theta and the cosine of theta. But we can find those things given this information, right? This is stuff we've done in previous sections. Given this information, we can find sine theta and cosine theta. So how do we do that? Well, what I like to do is draw a picture because, again, theta is in the third quadrant, so somewhere in here. And what does tangent equals 4 over 3? What does that tell us? Well, that tells us that our y is negative 4, since we're down here in the third quadrant, y is negative, and x is negative 3, right? Third quadrant, x and y are both negative. That's why our tangent is positive. So don't let that positive fool you. These are both negative, so sine and cosine are going to both be negative, right? So now all we need to do is find r, because our sine is y over r, and cosine is x over r. So if we can find r, then we know sine theta and cosine theta. We can do that by using Pythagorean theorem. We know that x squared, so this is x squared here, plus y squared equals r squared. And if you do this, you get negative 3 squared, that's 9, plus 16 equals r squared. So that's 25 equals r squared, so r must equal 5, right? And you could have also noticed that this is a 3, 4, 5 triangle and just jump straight to that. That's okay too. But our r is 5 in this case, so let me write a 5 here. So that means what? Let me erase this. That means that our sine theta, is y over r, so negative 4 over 5. And cosine theta is what? Negative 3 over 5. Let me make some room here. Negative 3 over 5. And you can also think of it as this is theta, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, same thing, right? But now we have sine, we have cosine, so now all we have to do is plug these things into our formulas and we can find the 4 exact values we're being asked to find, right? So now that we got the fun part out of the way, let's jump right into it. So the sine of 2 theta, that's equal to 2 times the sine of theta times the cosine of theta. So 2 times sine of theta is -4/5 times cosine theta, that's -3/5. So these negatives are going to cancel. And let's see, we have 2 times 4 times 3. I can think of this as a little 2/1, right? 2 is going to the numerator here. 2 times 4 times 3, that's going to give us 24. And then we have 5 times 5, so 24/25 is the value of the sine of 2 theta. And now the cosine of 2 theta is equal to what? Well, I believe that's cosine squared theta minus sine squared theta. So what is my cosine? -3/5. So I have -3/5 squared minus -4/5 squared. That is cosine 2 theta. So if I simplify this, let's see. The negatives are going to cancel because we're squaring, right? So our result here is going to be positive. 3 times 3, that's 9. Over 5 times 5, that's 25. Minus 4 times 4, that's 16. Over 5 times 5, that's 25. And I already have this nice common denominator, so I can just subtract across, and what I'm left with is -7/25. So we found sine of 2 theta and cosine of 2 theta. And now I'm going to have to erase a little bit so we can find the sine of theta over 2 and the cosine of theta over 2. So I'll go ahead and erase now. Hopefully you got it down. All right, so the sine of theta over 2 plus or minus. Do we have positive or negative? Let's think about this. How can we find out? Well, let's look at our interval for theta. Theta is between pi and 3 pi over 2. So if we divide everything by 2, then that should be the interval that theta over 2 is in, right? So that means that theta over 2 is between pi over 2. And let's see, if I divide 3 pi over 2 by 2, I end up with 3 pi over 4. Where is that? Let's think about it. This is pi over 2. 3 pi over 4 is about here. So our theta over 2 is somewhere in here. So that means the sine of theta over 2 is going to be positive, and the cosine of theta over 2 is actually going to be negative, right? So that's how you do that. Just rewrite the interval, divide everything by 2. So let's see, the sine is positive, the cosine is negative. So sine, we can erase this, we know it's positive. Now we're going to use our formula, 1 minus cosine theta. So that's going to be minus a negative, so plus 3/5 over 2. That equals, let's see, I can rewrite the 1 as 5/5. 5/5. That's 8/5. We're getting lots of algebra practice in, aren't we? Over 2/1. Now I can sort of flip the bottom and multiply, right? So then I have, let's see, 8 times 1, that's 8/10. Which is actually equal to 4/5 if I just divide the numerator and denominator by 2. And now let's see, should we split this up? I suppose we could. Yeah, because that's going to give us √4. If I split this up, right, square root of 4 over square root of 5. Square root of 4 is 2, so we're going to get 2/5. And now if I rationalize the denominator, so basically multiply by √5 over √5, I get 2√5 over 5. And I think that's the final answer. That's as simple as it'll get. So that's the sine of theta over 2 is 2√5 over 5. And I'm probably going to have to erase again just because I want to be sure that I have room for the cosine of theta over 2. So sine of theta over 2, I'm going to erase now. All right, so we earlier determined that cosine of theta over 2 is definitely going to be negative, so I'll go ahead and put the negative out here. And now what we have is 1 plus -3/5. So I'm just going to go and write that as 1 minus 3/5 over 2. And I guess I should have just gone ahead and wrote it as 5/5 since I I kind of knew I was going to do that anyway. That's okay. 5 minus 3, that's 2. The denominator stays the same. Make sure I carry this negative. Don't forget about the negative out in front as well. So now I have 2 over 5 over 2. And this is like 2 over 1, so I flip, multiply across. I'm speeding it up a little bit because I feel like I'll probably have it down by now. Negative, so this equals negative root, let's see where I'm at. This is gone 2 over 10. So 2 over 10, I drew the square root way too big, that's okay, equals negative root 1 over 5. And I can split this up again. That's like negative, the square root of 1 is 1. 1 over root 5. And if I rationalize the denominator, multiply by root 5 over root 5, I get negative root 5 over 5. So that is the exact value of the cosine of theta over 2. And I want to actually point out something cool that I thought about as I was working this out a little bit earlier. We didn't actually have to use this formula to find the cosine of theta over 2, right? Because once we found the sine of theta over 2, and we found the quadrant of theta over 2, we could have done a similar process that we did up here to find sine theta, right? Because we knew the sine of theta over 2, we had our y and we had our r, and we knew that our x was going to be negative, so we could have done that as well. And what we would have found is that x is actually negative root 5, r is 5, and our y, what was it, like 5 root 5 or something like that, I don't remember, but that would have been our y. I think it was 2 root 5. But that's another way you can do it that's kind of cool that's not using the formula. So obviously I did it this way because this is what we're practicing. But I thought of that earlier as I was working this out. So that's it for this video. Hopefully these examples helped. If you're in pre-calculus, hopefully you feel a little bit more comfortable working out these kinds of problems. Leave any questions below, any feedback in the comments. I'm happy to respond to all of it. Like and subscribe if you enjoyed, shared it with your friends. But most importantly, keep flexing those brain muscles, and I'll see y'all later.